projection, coordination dealio. And we're on time now.
Yeah, let's rock. Let's start.
Let me start. Okay, welcome to the second session of the HTTP working group for the week. We've got just 1 hour, unfortunately, and we have a number of presentations. So we're going to rock through those as quickly as we can. These are going to be the beginning of a number of discussions. It's not going to be the end. So please, if you do have comments, keep in mind that we do have very little time for each presentation. This is the Note Well, which you should be familiar with now. If you're not, then spend some time with it away from the working group and then come back when you're comfortable. And this is our agenda for the day. So we've got, what is it now, 6 presentations, hopefully?
In 60 minutes.
In 60 minutes. So do the math.
Yep.
Let's go ahead and get started, I think. Let's jump right into it. Emily? Yes, and this is the pink box, the famous pink box.
Those aren't?
No.
Can you work with them?
The right ones?
I think so.
Okay. Okay.
Hello. I'm Emily Stark. I'm here from the Chrome team. This is an old version of slides, so this is going to be a little exciting. We'll see how it goes. So I'm here to discuss a proposal called ExpectCT, which is can be approximately thought of as HSTS for certificate transparency. I suspect that many of you are very familiar with certificate transparency. If you're not, I'll give a little bit of background. CT is a system that allows public logging of certificates. So concretely, in the context of this presentation, you can think of a TLS server that has a certificate. That certificate gets submitted to one or more certificate transparency logs. Those logs provide a verifiable promise that they plan to incorporate that certificate in a way that can be publicly audited. This verifiable promise is called a signed certificate timestamp, an SCT, and the server will provide these SCTs on the connection to the client, which can verify in the TLS handshake that that a log that the client trusts plans to publicly incorporate this certificate. So certificate transparency, ideally in the future, we would like to imagine that all TLS clients would verify certificate transparency information on all connections that they make. And doing so would have a number of benefits. Domain owners could monitor the logs for certificates that they don't expect to appear there. And they would know that any certificate that is accepted by a client would appear in a certificate transparency log. And it also provides value for other parties who might want to, say, monitor for CA misbehavior. So that's an ideal future, but today, site owners don't get the full security benefits of certificate transparency because there's no way to guarantee that any certificate that is accepted by, say, a web browser actually appears in the CT logs. So site owners today don't get protection against a misissued certificate that doesn't actually appear in the CT logs. So next slide, please. So ExpectCT is basically an opt-in, kind of like HSTS, an HTTP response header that a site can send to ask the browser to kind of hold them to CT, to require that any connection to this site in the future for some period of time comes along with valid certificate transparency info. So this is kind of a straw man syntax from the draft. Probably very familiar from HSTS. When a site sends this response header, it asks the browser to remember that the site should be connected to with CT compliance, has a max age, and much like HPKP, has a report URI so that the site can be notified of violations or misconfigurations. And also, much like HPKP, comes with a report-only mode. One example use case for this is that a site might want to kind of gain confidence in its operations before going into the enforcement mode, where their users might start seeing failed connections. So let's see, a couple couple high points I want to pull out here. One of the main goals here is to do something that is easy to deploy, familiar to site operators, especially easy to deploy soon. And I'll talk. I'll describe that a little bit more. But also the overall goal here is basically to give site owners a way to ensure that all the certificates that UA accepts for their site appear in the public CT logs. So I'm missing a slide after this one, but basically why I say that that it's especially important that this is something that site owners can deploy easily and soon is because of what might be a little bit of an elephant in the room, which is that Chrome recently announced plans to require CT for all new certificates starting in October 2017. So you might be wondering how these things interact, how the Expect CT proposal interacts with this Chrome CT requirement date. And I'll say a few things about that. So first of all, we think there is a good chunk of value to be had in Expect CT in kind of transitioning the ecosystem to this Chrome CT requirement date and any other CT requirement dates that might be announced in future by other browsers. So for example, if a site is getting certificates from a CA and the CA is embedding the SCTs into the certificate, the site might want to use Expect CT before the Chrome CT requirement date to make sure that their CA is doing things properly so that they can find out now, if not, instead of in October when their site breaks and it's out of their control. Let's see. So Expect CT is sort of a step on a gradual adoption of CT for Chrome, and we think it can also potentially be a step on a gradual adoption of CT in other browsers. And then, of course, there's also the consideration that the Chrome CT requirement date is for new certificates. So any certificate issued in October 2017 or later will be required to have CT information, but that doesn't protect site owners from old certificates that were issued before October or backdated certificates. So if a misbehaving CA hypothetically decides to backdate a certificate and not put that certificate into the CT logs, that certificate wouldn't be subject to Chrome's CT requirement. Okay, ignore this. Go away. Can you go back? Thank you. Okay, so my actual next steps here were to pull out a few questions and issues that came up on the mailing list in the past few days. So let's see if I can remember them off the top of my head. So one of them that came up on the mailing list was syntactically whether there should be a set of new HSTS directives or a separate header as the draft currently proposes. Another one was the question of how exactly the report-only mode should behave. So the issue there is that a site owner might expect and might want the report-only mode to be remembered or cached the same way that the enforcement mode is. But that's not how HPKP report only works or CSP report only. So there's a question there of what is useful to site owners, how people expect report only mode to work, and what is valuable for debugging or uncovering any misconfigurations that site owners might encounter. And finally, there is a question of what it actually means to enforce CT, which I haven't talked about in this presentation, and that's because browsers kind of have their own idea of what it means to enforce CT, and that may vary from the list of logs that they trust to the number of SCTs that they require, et cetera. So Expect CT as defined in the draft is the site asking the UA to hold them to kind of whatever CT policy the browser has. And so the question is whether that is useful to site owners, whether that is what site owners want, or if there's a desire for some kind of more flexibility or for the Expect CT draft itself to define a policy. So I'm looking for feedback from anyone on anything, but I'm specifically interested in feedback from site owners on what they'd find valuable and useful. Thanks.
Yeah, Martin Thompson, not a site owner. I think the point about determinism is one that really needs a bit of consideration. The sites that put this in their header fields will have to expect a certain degree of service when they put this in the header field. I mean, if your policy is, like I believe some browsers have currently, which is to ignore CT entirely, then that may not jibe very well with the opposite policy, which is the most strict possible policy that you can imagine for CT. So I'm not sure that there's any good thing I can recommend, but having at least a baseline, which is you must at least go this far, would be good. Setting some bounds on what the policy might be would be very useful.
So if I'm understanding correctly, you're saying something like there's sort of a minimum bar that an expect CT site must meet, but a UA is free to enforce a stricter policy if they'd like to.
I think that's true, but it's also true that if you have some uncertainty about the extent to which a browser is going to enforce policy, then you end up risking being locked out of your site, and that's probably the harder line that you need to draw, which is if someone's going to be stricter about particular aspects of it, then now I speak in ignorance of CT, and Ryan's going to tell me that I'm an idiot, but I would like at least the maximum to be set rather than a minimum.
What if the maximum is less than what a browser wants to enforce?
Then we have a problem.
Yes, that's why we don't want to do that.
Well, maybe that's one of the things that we can do here, or maybe in this the transparency working group.
Right. So Ryan Sleevey, I'm the one who made that announcement on October. So it's all my fault. Blame me. So, you know, I think one of the things that we've seen, that we saw, just sharing an implementation experience that guided and shaped some of this, and the feedback heard was extended validation. Chrome had a policy that extended validation certificates must meet a particular CT policy. And what we saw was in fact a number of CAs unable to meet that policy because they have trouble with reading comprehension. We see this with enough CA incidents that reading comprehension is a very high bar for running a CA. But it was enough that there were a number of EV certificates out there that weren't even able to meet, you know, that policy. So I do take your point, which is, you know, there's a need to specify policy, but you know, on the other hand, a number of site operators weren't receiving feedback that their certificates weren't working and understanding where their certificates weren't working. And so something, you know, like the report only mechanism as the feedback, right, to sort of go through reporting. It didn't sound from you know, your discussion of policy constraints. I certainly can appreciate setting the maximum, right? Saying the most restrictive policy, but expecting everyone to enforce that. But do you see that as being a normative requirement then to go forward with expect CT, that you must specify the policy in the document as the normative requirement?
So can I just do a quick interrupt? And this is great conversation, but
Offline.
We're incredibly time constrained.
Yeah.
And it's not so much yours, it's the chain of reactions. Can we just have a quick discussion of whether we think it's interesting to continue this and perhaps start working this area in this working group? I see thumbs up from Martin. Anyone else have any strong opinions about that? Should we do a hum?
Do a hum.
Let's do a hum. Who thinks that it's interesting to work in this area for this working group? I won't say adopt this document because I don't think we're quite there yet. We've just started talking about it. But is this an area that's appropriate for this group to work on? Hum now. And who thinks that it's not? Hum now. Okay. Subodh.
Hi, Subodh Ankar. I was wondering whether there's plans to continue working on this for other protocols apart from HTTP as well. For example, when we add these new features like HSTS and CT logs, so these things are nice to have for in the TLS layer. We violate these abstractions all the time, and we put this in the HTTP layer. I totally understand why you're doing this for ease of deployment, and it's much easier for sites to add HTTP headers right now than to wait for their OpenSSL update to get this. But I would not like to see this stop here. I would love to see a TLS extension which has a CT, whatever, expect CT as well, so that we have a good forward-thinking solution for this, not just a stopgap.
Yeah, I agree. I am interested in having a similar discussion for OCSP stapling. I think the difference here is that I would like, for expect-CT, I would like to do something that browsers can implement and sites can deploy very quickly. Because for us on Chrome, a big chunk of the value comes from this period between now and when the CT requirement date hits. But for something kind of, and also because expect-CT kind of has a natural shelf life built in. But for something like OCSP stapling, something that I would expect to be longer term, I think some other mechanism might be better.
Right.
Can I just throw in one more note?
Sure.
I uploaded this as an experimental draft. I don't really know if that's if that's
We'll talk
appropriate or
about
not.
that.
So
Yeah,
I just
yeah.
wanted to throw that out there.
Actually, I have one quick question, hopefully a quick question for you. Has there been any discussion about the potential relationship with Mike West's work on origin-wide policy?
Sort of. I mean, I think it's sort of the same answer. Like, I don't really see the origin security policy being something that will be implemented and deployed in the next, that we could implement and deploy in the next years. So
You want something quicker?
yeah.
Okay, no worries. Thank you very much.
Thank you.
Sure.
I will endeavor to get us back on time. Okay, I spoke briefly about cache control, response header immutable when we were last together in Berlin. So since that time, I put forward a draft, and we'll talk about that really briefly today. So the basic problem, Facebook reported that 20% of all of their HTTP responses were 304, and most of these were for resources that had not existed for as long as the max age on the resource. So it didn't really make sense that people were revalidating them. And it turns out this is because people press reload a lot on social media. Next. So we've got a cache control extension, which is well defined by the caching RFC. It's a simple mechanism to assert that fresh responses would receive a 304 if they were to be revalidated. Therefore, skip the revalidation and your reload gets faster. This meshes well with version URL design patterns where a particular resource only ever has one version. Next. Great. We got running code. So this has been out in the field in Firefox for about 6 weeks. Facebook has deployed it. BBC has deployed it. The interplanetary file system includes it. I don't really know what that is, but it makes me sound awful smart and future looking. There are a lot of reports. Page load times on reloads were as much as 50% improved, 90% fewer transactions. Obviously, it's based on the content and whether people are pressing reload a lot. Do they like me? Do they not like me? Reload. Next. All right. So there's an internet draft out there, immutable 00. An example up top, you still have a max age because immutable only applies to still fresh responses. And I got a bunch of feedback on it, especially with respect to intermediaries, all of which makes sense and is pretty easy to address, and it requires O1. Next slide. All right, so 7234 defines cache control extensions and a registry for them, but that requires IETF review, which means we pretty much need to turn this little thing into a document in order to get it into the registry. Is this something that we're interested in working on, is basically my question.
And this is the beautiful thing about having two chairs now. We can have a clean separation of concerns. I think there's been a lot of discussion of this, and from what I've seen, a lot of interest in it. I already saw a thumbs up in the audience just after you asked that. So I think we can just probably, unless there's any people that want to ask questions or point anything out, we can probably just do a hum. Let's do a hum, since the lines are gone. Who thinks we should adopt this document? Hum now. Who thinks we should not, or we need to talk about it more? Hum now.
2 hums yes from the Jabber chapter.
Okay, it sounds like we're going to adopt the document. Great,
Thank you.
thanks. And next up is Ted. Can someone take over Jabber channel?
Let's do it at the same time.
Okay.
Okay,
good.
so as you folks may remember, in Berlin, we talked a little bit about shared dictionary compression. In particular, Charles said that Yandex was quite interested in getting an actual spec for it, since the spec for it that was available did not seem to actually reflect his expectations. So what is it? no, that's a different, no, not that. Okay, so this is it on one slide. This is the entirety of the idea. It's an HTTP 1.1 compatible extension that supports inter-response data compression by sharing data, right? It's a little dictionary you send across. And then whenever you look at your CSS or footer or JavaScript or whatever, it references the dictionary rather than getting it for fresh. It's rocket science. Anyone think that's right? No. Okay. So the draft is out there now. Draft Lee SDCH spec. Unfortunately, Wei Xin was not able to make it, so he sent me. I'm really not sure why he didn't send somebody else, since there are lots of other people he could have sent. Look, Ian could have done this. Next slide. The current state of play. There is some deployment, but no standard specification. There's been interest expressed in getting a specification done on some, I'm not sure whether it be standards track, informational, whatever. The current authors are not available to drive this, but Charles McNamee, Charles has said that he would be able to do it. He was unfortunately not able to be here, but I have his proxy, a little token that says 1 draft's worth of effort from Charles that I'm allowed to spend if the working group is interested. Okay, there's nothing in the Jabber chat room. I see 2 people at the microphone.
Yeah, Eric Squirrel. So I did skim the security consideration section. I don't see anything about side channel attacks on compression. So what stops this from becoming the same cesspool that we've already seen repeatedly?
Ryan, do you want to answer that?
Nothing.
Oh, good.
Ryan's leaving. Yeah. So to this issue, part of what's happening, like Ted said, is there's an implementation. There was an early draft, doesn't quite match the implementation. There's an implementation that needs to change because, by golly, there's security considerations, and not just security considerations, implementation considerations that want to go forward. The Yandex team is quite interested in this, and like Ted said, he has a token to sort of go forward to see if this is something that is a tractable, is there a space that the solution could emerge from, or is this going to be the sort of side channel? So more or less the draft is a starting conversation. I think, we're very concerned about not just that, but also, reliance on OpenVC-diff, a variety of things that sort of come into play here. But if the working group wants to go forward and spend the energy to discuss, that would be fantastic.
Sure.
So just to kind of come back a little bit, it was very clear from Charles's discussion with us on this that they did not see this draft as ready, and we don't either.
Mm-hmm.
So it would be the starting place and not the finishing.
Sure. I guess my question is there some theoretical reason to believe we can remove the side channel attacks here? Because if not, maybe we should do that first before we start talking about the standardization effort.
Okay, so Martin behind you is shaking his head no. Do you wish to add to this, Martin?
Yeah, so Martin Thompson, I think there's like a series of foot guns aimed in varying directions, maybe not at feet, but certainly other sensitive places. There are ways you can deploy this potentially that are safe, but there's a very sort of narrow line to tread when you deal with this sorts of things. Even if you think it's safe, it's probably not. And this is a discussion we need to have. I really only got up here to talk about the sort of broader problem, which is that we now have 2 drafts in this area, potentially more, and an array of solutions. We should first decide, well, whether we can actually ever deploy something like this. I know people have and seem to be happy with them, but do they require, well, okay, Ryan's not particularly happy with them. Do we want to put something like this out there? And then what is the right way to do this? I have a slight preference to approaches that use content encoding over what we're going to hear about later, but that may change based on later presentations.
Okay.
Yeah, I guess all I would say about this is we basically threw up our hands and gave up with this for headers. And so, I mean, more or less, right? And so, and that was something that was actually really super high priority, and we burned an enormous amount of time on trying to get security analysis of. So just like, I guess if we're going to be voting for whether we got this, I'm going to be voting no until someone shows me a paper that like demonstrates it's safe.
Okay, so I don't think we're going to ask for adoption today. What we're mostly putting it forward to see if there's people in the room who'd be willing to work with Charles and others to look at the problems in it, right? And so I certainly was not planning on asking the chairs for adoption, but to see whether there's energy in the room to work on this class of problems / approach.
So Ted, we have another presentation in the same general area, so maybe we should go through that and then revisit this part of the discussion.
Have the bigger discussion, yeah. Vlad?
Yeah. Hi, Vlad Rationale from Cloudflare here. I'm going to talk about my draft HTTP2 compression dictionary. Basically, the idea is that you can use data from one HTTP2 stream as a dictionary for broadly or diff-late compression or any other kind of compression, even VC-diff compression, as a dictionary for the following streams. And that basically improves the compression by a significant amount. So we can also add maybe static dictionaries to this proposal. And basically what you do is when you want to set a stream as a dictionary, you send a special frame called set dictionary frame with the ID you want to use for that dictionary. And the client knows, okay, I need to keep part of the data for later use. And after that, you just send a use dictionary and you use that data as a dictionary. And the nice thing is you can also append several streams into a larger dictionary, and that way you can look into several previous files or whatever. And so the rationale is obviously that, in theory, HTTP1 uses large assets and HTTP2 uses smaller assets, which is, I'm not sure that's true. But CPU time is getting significantly cheaper. We basically get 2 extra cores for the same price every year. And with Cloudflare, use gzip-8 dynamically, and we see no issues with that whatsoever. And next year, we're going to see some Skylake CPUs with FPGAs, and FPGAs can do very fast dynamic compression. And, today we see many new formats like broadly and sandwich. And as a CDN, for example, you have to decide, do you want to keep all those files in your cache, just in case one wants a gzip, one broadly, or you just, keep one copy and then you just dynamically serve whatever content type you need. And if that's the approach, then dictionaries improve the compression ratio. And next. So the benefits are clear, yeah. We waste less bandwidth, we see faster page loads, blah, blah, blah. And the special use cases for CDN, again, is when you do your origin pool and you have a long-lived persistent connection to the origin over HTTP2, then you can basically save a lot of bandwidth. With Cloudflare, I have a tool, it's called the Railgun, that does a delta compression to the origin, and it's absolutely stunning. And that's like, if we standardize that, it will be a very, very big use case. And next. So just to give you some glimpse of the performance we're getting here, I did some analysis over 2,000 top Alexa sites. And details are not important, but basically I just scrolled over websites, simulated the dictionary compression. And next. And here we can see, for example, the blue line, that's the average compression that we got over the 2,000 sites. So the blue line is where you just load the website for the first time. We can see there's like over 4% improvement. And that's just from using the static dictionaries that I created. But the orange line is when there's like another click. So you load the next page on the same website, and then the compression goes up to 18% if you use large dictionaries. That's with broadly-7, by the way. And if you do another click, that goes up to 25%. And that's a crazy, really crazy compression improvement. 25% is something you can get by just any other algorithm. Next. And that's the median numbers, they're similar. And next is a total. It's very similar. We see almost 25% for the total of those 2,000 that we saved. Next. And that by percentile. We can see at the 19th percentile, the savings are 50%, which means we actually saved 2x it's a half the size of the original data, just thanks to using the dictionaries. And although I report -7 numbers, they're absolutely the same for -5, -6, whatever. It's very similar numbers. And here just an example. If you go from deflate-A to deflate-4, you just get 1.04 improvement, and we do that because we think that's worth it. Whereas if you use dictionaries, you get 1.46x at basically the same performance as far as CPU concerned. Next. So the main concern obviously here is security, like the previous presentation, and seriously, it's hard to really know if what we know today is even sufficient to estimate the performance implications of this suggestion, but at least I think we could give some tools to the client to being able to disable on a per stream basis. Although also I heard a proposal to maybe use several contexts, like define for different streams which can or cannot be used to compress in between, and let the client decide, because the client has more data, who's the original of the request was. And basically the compression would be disabled by default. So if you really want to use it, you have to understand what you're doing before you enable it. And if you're an intermediary, you shouldn't use it unless you've been told to. And just a reminder, today most websites are non-HTTPS websites, and they really, at least if you give them more incentive to be HTTPS, it's better than plain text, I guess. Maybe not everyone would agree, but that's my opinion. And some websites just really don't have that data that would be compromised by such compression, and I think we should let them at least enjoy the benefits. And next. So another question was how it compares to the previous presentation. So that's not a competition, that's completely different use cases. Sandwich is great when you can download a big dictionary ahead of time or out of band. And we also explore this use case for different things. My proposal can work with VCDIF, obviously, and also as a dictionary. And if you compress with the VCDIF before and then use broadly, for example, with cross-stream compression, you obviously will gain more. Obviously, you don't need, there's very little overhead. You just send several bytes to set a dictionary and several bytes to use it. And you don't have to use the whole stream as a dictionary or the whole asset, just some first bytes, because those are the important for the creation of the window. Also, we've seen much better compression ratio in the use case where you do use cross-stream compression for broadly than for sandwich broadly. And the creators of broadly also support this statement. So yeah, you can append streams together, which means you have better efficiency. And you also, because you're at the HTTP2 layer, you know which data was sent, you know exactly what the client has. You can use dictionaries much more efficiently than you can do on the HTTP layer, or on the application layer. And again, minimal overhead. Next. Also, not very important, but you can also do more optimizations to the current broadly or deflate implementations to make it even more efficient than it is today. And I'm done. I think so. Yes.
So your suggestion of making it opt-in is interesting. I mean, one way to tackle, without taking a position on this sandwich, right? One way to tackle these side channel attacks would be to attempt to narrow the range of things that could be compressed to things that we thought were somehow safe. So I can imagine a couple structures like that. One can imagine saying something like CORS prefetch, for instance, where you said, this is cross origin, but it's coming from this. Do you want to do it or not? You can imagine only doing only allowing cross origin compression when you strip cookies. That probably would actually not work, but you might imagine. I mean, that would be one way to. And so the underlying problem with all these side channel attacks, right, is that the attacker manages to basically get you to make a request on his behalf with your context, not his, because of ambient authority, right? So stripping cookies might work for that. I don't know. I don't know what fraction of things that would effectively break. So I don't know. I guess the reason I got up was because I thought that everything else I've heard about defenses has largely been about, oh, how do we handcuff the compression mechanism enough that it can't be used as a side channel? And so I thought it was interesting you suggested instead of handcuffing the compression mechanism, limiting the times you use it. And if we're going to adopt something like this, probably that seems like the most attractive venue for protecting ourselves from it, because I'm extremely pessimistic about our ability to design a compression scheme which doesn't have these side channels.
Okay.
I'd like to point out that this approach would also benefit would be a benefit to people using web APIs across data centers, because it can be used to compress many smaller, tiny requests and responses. And in such cases, it's often hard to build a shared dictionary ahead of time. So using this kind of dynamic approach might be beneficial, I think.
Yeah. One thing I tested was when you type in Google search, every character you type, you get a new JSON file, and that's very beneficial in that use case, for example. I don't know if I want to pull all of this.
Yeah, I think we're just, it sounds like it's a continuing discussion. I don't think either one's ready for adoption, so it's just a discussion on this, I think. Okay. Okay. So, Subodh.
Subodh Iyengar. So in sites like Cloudflare, you guys have multiple different domains on the same connection, and you have a giant sort with all the domains in them. So are you not worried about the connection coalescing effects of browsers and how this works with?
Yeah, absolutely. That's why I said that we will let the browser decide if they will allow or not allow cross-stream compression. They might indicate that one website will have context 0, the other will have context 1, and then we'll just use cross-stream between those websites.
Right, but the property is that the websites would want to opt into this, right? Like, so I don't. The websites would want to say that, hey, I don't want to share a stream. I don't want to share a dictionary with another site, even though I'm running on the same connection as another site due to being hosted on CDNs.
Well, I hope they don't use assets they don't trust, right? But yeah, also something to consider.
Martin Thompson, I think the simplest thing in here is to say that this is constrained to an origin, and
that's
don't muck around.
Initially, I think that's the best approach and the safest one, and then we can see from there.
Okay, thanks, Vlad. It sounds like we still need to have discussions on both of these approaches and how they might be used and what the impact would be. So I think we just want to encourage folks to continue that while we're all here as well as on the list.
Makes sense. So Barbara, are you going to speak tonight? Oh, nice.
Oh, do I get to press a button? Craig, can you? Is it Craig Pratt? Can you do whatever it is in the Meet Elko app that you need to do?
Make yourself known to us.
Yes, I think it's cue yourself. Aha. And now I get to press the red button.
That's 2 times in 2 sessions, Mark.
Awesome.
Hello.
Hello.
Oh, hi. This is Craig Pratt. I'm presenting on the live random access CR, but you'll notice that both Barbara, and I'm not Barbara, by the way, first of all. Barbara and Darshak are both there, but they must believe in my presentation skills so much that they're having me do this remotely, or they're smart enough to know that this is a topic that that somebody else should be presenting who's not there. Anyway, do you have my slides handy, Patrick?
I did not receive your slides, so no, I don't. We can
Can I
swap
present
speakers,
them?
and I can go
Can
dig
I-
in.
Can I present remotely?
If you
or-
can present locally, do it now. We have 10 minutes, so.
Sure.
Okay, so why don't you go off and we'll swap the sessions around. So next up is, I think, Takashi?
Do you have your slides? I'll just give you the dongle.
Yeah, give me the dongle.
All right.
And you can do that in the background. Just a second. So it's come up. One moment. Okay.
So I'm Takeshi from Chromium team. So I'd like to talk about kind of how to evolve the WebSocket and maybe other web messaging in the HTTP2 era. So this is kind of one possible solution for this kind of questions. So, yeah, so I could just start with talking about the history. So we've shipped WebSocket functionality in 2010 and 2011. The WebSocket RFC has been published, and it got a very good adoption in the last 5 years. And also, this working group has published the HTTP2. And in parallel, the web standardization bodies such as W3C and WebWG has evolved. Please just go to the next slide. Evolved APIs in parallel to the WebSocket. So, so one thing I'd like to talk about is we've been actively working on the Fetch API and Streams API, which is kind of a successor of the XHR API, which is very legacy and cannot handle a bunch of answer to a lot of the demands for such as streamed, uploading, downloading, and kind of full duplex messaging like that. So, but we are kind of going to resolve all these issues by these APIs. These kind of actively shipped and being evolved to solve these issues. And so we've been kind of sporadically having some discussion about how we should, how the WebSocket for the HTTP2 era should be like. So in 2013, we've tackled these problems by kind of trying to introduce some WebSocket mapping to HTTP2 frames directly, or just layering the WebSocket WebSocket 1.0 just directly onto the stream of HTTP2 or like that. So here's some data. So we are still having some WebSocket adoption based on the user metrics analysis of Chromium. About 0.7% of web pages visited are using the WebSocket. So we should just think about this as a kind of high adoption. And we should just take care of this for the HTTP2 era. So next slide, please. So in the last almost 2 years, we've been discussing what the right thing to do. And this is one solution I propose, me and Wen boys are proposing. So that is just kind of introduce a new frame type. So I could just say that this is a new media type that is based on the WebSocket framing, but dropping all the transport layer stuff such as ping-pong signaling or cross signaling, and some things unnecessary such as masking, which we've introduced for the because of the cross-protocol attacking or like that. But just use the WebSocket framing, as we already have a lot of library and sub-framework that are already using the WebSocket encoding, such as the length code, length header, like that. But we don't introduce any new mapping or kind of intrusive designs using the HTTP2 layer stuff, but just keep us just inside the HTTP 1.1 semantics. So I mean that we use this framing inside the HTTP response and request body, message body, date part. So I'd like to introduce this as a media type and use the story for the web programming would be using the Streams API and the Fetch API to do streamed uploading of data and receiving of data, and possibly that could be just full duplex to be almost equivalent to what WebSocket can do. And the story could be, so I should just talk a bit about what we are doing for the Streams API. So we are defining the readable side and the writable side of Stream API, which is kind of going to represent the data sink and source of data will be lapped by these interfaces. And we are also introducing the concept named the transform stream, that is kind of connecting this readable and writable stuff with a transform stream that could implement such as a deflating stream or JSON encoding and parser, or for example, this kind of framing could be also implemented in the form of this transform stream concept. So the first step could be introducing the transform stream for handling the wish protocol framing. And then, so as we value the compatibility with WebSocket, as we have a lot of the already deployed WebSocket stuff and assets, so we could just proceed to bind the WebSocket API with the wish and HTTP2 together with some fallback mechanism or some handshake or something, and then just allow all the existing WebSocket users, customers, to easily migrate to this stack, so WebSocket wish over HTTP2. So that's the story we are kind of selling. And I'd like to also mention that we are going to take care of a bunch of the WebSocket compatibility stuff. So not only the framing, but the people are heavily using the sub-protocol systems, which WebSocket 1.0 had, that is kind of proposing, allowing the client to offer the sub-protocol candidates to be used, and the server responds with a chosen sub-protocol. So this happens inside the WebSocket semantics, but we could just implement this in the form of HTTP 1.1 semantics, such as the one proposed way is using the accept header and content type header to declare the offered sub-protocols and allow the server to choose one and respond in the form of the content type like that. So not only this topic, but we've been discussing how we should guarantee the kind of enough compatibility with WebSocket, but almost all the answers we currently have been summarized into the ID we published for this meeting. So I'd like you to take a look at the ID and give us some feedback and your opinion about whether this makes sense for the evolution of the WebSocket for the HTTP2 and possibly quick or some more future protocol layering. So that's it.
So Takeshi, we've only got like 3 minutes for comments, but I'm actually very curious how many people have read this draft.
Okay. I think, yeah.
Summarize? 3 or 4.
Yeah. Martin?
Yeah. Martin Thompson, is this just service and events on Crack?
So what?
Service and events. Okay. Since the past. So service and events looks very much like what you're describing. WebSockets was intended to replace service and events.
Yeah.
And now we're sort of coming full circle. So I caution that this has very poor latency properties in certain circumstances. And service and events had a bunch of other problems that this potentially suffers from as well.
Yeah, kind of, yeah. Actually, we encountered those issues, but And basically, I think even considering those issues, we should proceed with this path. And yeah.
So I think that we're just about out of time for this one. I think that there's maybe two threads here. One is, what is the general future, if any, or the evolution of WebSockets? And it's not at all clear to us as chairs that this working group is the right place for that discussion to happen. I think, good nodding. And then the other discussion is if that future evolution of WebSockets has a relationship with HTTP in some fashion, what should that look like? And so maybe the next step for this might be a barb-off or a separate list, or resurrecting the old WebSockets list or something. Hi-bye, I guess it was.
I keep getting told to go to dispatch.
Yeah, dispatch is a place.
interesting,
Yeah, and we can have that discussion there. Okay.
Thank you for the presentation. We can bring Craig back. Craig, I am so sorry. Your presentation was classified as spam by Gmail.
He has to request being on the queue, I think.
Give me the dongle back.
Oh, dongle, yes. I'm going to try pressing the button anyway. Okay, here we go. Awesome.
Hello. Did I say spam? Okay. Wow. Okay. I'll try to make this quick.
To be technical, Gmail called it spam, not me.
Okay. No problem. Okay, so go ahead and go forward a slide here. So this is a few people have been down this road and no one has survived. But basically, this seems like a pretty simple problem that no one has quite figured out the right answer to. How do you have a live or continuously aggregating resource, which you can also support random access on using range requests? So there's a number of examples of this. I come at this from a video angle, but there's more. It seems like there's more examples now than there have been in the past. Anyway, next slide, please. Okay, so here's the basic problem. In a byte range spec, a last byte position is optional, but in a response, you must provide a last byte position, which implies that a partial content is a bounded response body. Next slide, please. So here's some of the things that have been considered. This isn't even all of them. Just changing the ABNF for the bytes range unit, and hope to not blow up too many things. New range unit for live. This is what the current draft was that this time was allocated for. We've allowed that to expire. I think this qualifies in the too rusted to be usable. And Roger Combs also demonstrated there's a variety of software that can't handle accept ranges with anything other than bytes and none in them. So now we have another option, which is really the fourth option that's been proposed down this path, which was a late submission. My apologies for that. Next slide, please. Well, this is pretty simple. The concept here is that the client can passive out. Boy, some of this formatting got messed up. My apologies for that. That basically the client, well, there's two important things that a client who's dealing with live content needs to know. It needs to know, first of all, it's live, and secondly, it also needs to know where is the point where I can still randomly access content without getting flow controlled by the production of content on the server. So currently, the open-ended byte request serves that purpose perfectly. If I do bytes 0-, the server gleefully gives me back the current content range, and then the star is a good indicator that the representation length is unknown. But what we're proposing here is the possibility of using, instead of changing the ABNF, well, let's work inside the current ABNF and let's just say, well, what if the client uses a very large number instead of star or some other mechanism that requires a new BNF? In this case, the client would pass some very large number that in this case, this is 2 to the 64th or 2 to the 63rd minus 1 or something like that. Something that's hopefully pretty easy to parse. If the client sees in the response that same number back, see the equals, it's supposed to have a bubble around it, then it knows, hey, this is a server that understands how to return me a live response. That's the client's indicator that it can do random access. So at this point in time, at the end of this exchange, the server knows, well, the client knows where's the randomly accessible content end, 944083883, and it also knows that it's live content that can provide unbounded range responses. So in response to that, you can see here it's actually providing a response that starts earlier than the random access point, for instance, to establish the beginning of framing in the content, and it wants a response that's unbounded. Next slide, please. Current server that doesn't understand any of this will, when you provide a number that's too large and out of bounds, will simply give you back, just like with the open-ended range request, will give you back some smaller number that represents the current bounds. Now it's important to notice between these two with live content, it's common for this number to be going up continuously. So here we were at 994.08383, and here we're at 994.1000. But the important thing to the client is, hey, wait a minute, this guy didn't give me back the same large number. Therefore, he doesn't understand anything about dealing with large unbounded range responses and live content. I'm going to treat him just like I'm going to have to do this some other way, polling or some other mechanism. Next slide. So that's it. Hope that was fast enough. Any thoughts on this?
Nice and fast.
On the last slide, the example for the server that doesn't know about this, wouldn't it return range not satisfiable in this case?
It's only if the start of the range, range not satisfiable is reserved before when there's zero overlap. So as long as the start of the range is before the end of the range, the accessible content range, you should be getting a partial content according to RFC.
Okay, who wrote that?
Yeah, so Martin Thompson, this understanding the constraints that we're operating under, this doesn't seem at all crazy. It's awful.
High praise indeed.
But this actually looks workable, which is the first time I've seen something like that in this area. So congratulations, thank you for coming up with something clever.
Yes, indeed.
Well, we have to thank Patrick for some inspiration on this one. I don't think this is exactly what he had in mind, but it's close, I think, to something he had suggested us.
I think this is workable.
So I think this solves a problem that some people are having that's really annoying. And so I have no problem with proceeding with something like this.
So I guess my question is and I haven't had a chance to look at the draft, is it, just documenting a pattern of use? It doesn't seem like there are any new protocol elements here.
Well, there's definitely an understanding here between client and server. I don't know how we characterize it exactly, but.
So so I think our hope here is to actually probably publish it as an informational RFC or something, so that everybody kind of starts using it this way, hopefully, whoever wants to use it.
So my suggestion would be we get more people to read the draft and we do a call for adoption on the list.
I think so, yeah.
Mike Bishop, can I just clarify one thing? Is the exceptionally large number, is that a magic number, or does the client just pick something?
Yeah. I thought about using a magic number, but right now the client can pick whatever it likes. I thought magic number was just too gross, but I was thinking like 2 to the 63 minus 42 or something like that would be great, but no, it's a client's choice. What's important is the equality test on the previous slide. So the server basically acknowledges its support by returning the same number back.
We're going to cut the queues now.
Yeah, there's no need for a magic number here. I think this is fine. There is potentially a sort of interaction here where the client, a client that receives a response in this form that doesn't realize that it's made this request they pick a large number, and that comes echoed back. And if they weren't implementing this spec, a server that does implement this spec could end up confusing the client.
User code.
That is the hazard. So
we're out of time.
Oh, okay.
Yeah, we're out of time. Sorry.
We might need to write
I'll
something
give that
down
some thought. Yeah.
Right. My only question now is, it sounds like people want this to be informational. It could be done outside the working group, but my gut feeling is that having it in the working group would get better oversight and a better result. Are people happy with that? I'm seeing a lot of nodding heads. Mike, really quickly.
You're sending something different to the server and expecting it to send something precise back to you. That is a protocol. So.
Okay. All right.
We got a lot done. 6 presentations in 60 minutes. Thank you, everyone.
Thanks a lot. We'll see you in Chicago. If Chicago's still there.
Happy Thursday.
Snafu, Craig. That was great.
No problem. Blame Google. Or Gmail. Bye, guys.
Shrug emoji.